So thank you for joining this session, Price Intel at Finastra. My name is Romain Gilles. I'm French, as you know, you may notice. I'm development manager at Finastra, and who knows about Finastra? Not that much. So Finastra is the joint between Mysis and D+H. We are the third fintech in the world with more than 10,000 employees, 9,000 clients. We deliver the broadest portfolio of solutions, more than 1,000, for their critical missions and help them in their day-to-day business. We offer our solution on-premise and in the cloud. So, we have 80 biggest banks over the 50 biggest. So today, I will talk about treasury and capital market story. But we also cover the retail banking, transactional banking, and lending. So what about pricing at Finastra? First of all, let's see what we do in the past. 30 years ago, we mainly have two-tier applications based on C++ or C fat clients. The model was strong and driven by RDBMS. Everything was able to stay and fit in a single server. But in order to achieve resiliency, we use AV server, really expensive, in order to achieve physical resiliency. But those expensive servers were able to compute report in a couple of minutes or even in a couple of hours, even days. And the increase of the business and the reporting and the pressure of the regulations lead us to move to something else. And in order to be able to scale with the data, we move to compute grid. We start to develop three-tier architecture, Java, G2E, and GMS come into the party, and the computation become more and more complex with the complexity of the products we have to price. And as we move to the data grid, the database and the network start to become a bottleneck. For that, we introduce a layer of cache. But now, the issue is even bigger, because the regulation increased the pressure and request us to be able to provide homogeneous report on different source of information. Clients can have more than one front office system. Let's say, for example, in Finastra, we have 4 front office systems. We have Condor Plus, Surface, Calypso, no, not Calypso, it's a concurrent. We have also Summit and OPIX. Each of them are the best for certain subdomain of the front office solutions and problems. So our clients have exactly the same issue than us. We need to be able to aggregate and compute the data against this entire landscape of front office system, even our competitors. So I will give you an idea of dimension of what we have to compute. For the PFE, which is a middle office report for the risk analysis, you have, let's say, 3 different input, 3 orthogonal input. One is the thread. This is the pivot of the computation. Everything runs around the thread. Then you have the scenario, which are the potential value of your market data. This is how you stress your system. And finally, you have the state dates, your projection in the future. And if you multiply those 3 inputs, let's say you have a million thread, which is, let's say, a middle tier front office system. You have 10K scenario to simulate for every day. So you end up to produce millions of PV. And this is what we have to produce in seconds, minutes, but less than hours nowadays. So what about Finastra? Finastra is dealing with 10% of the trade in finance, 8% of the daily FX trades. We are about to have 200 million of retail accounts. So all those values put us in the domain where we have to scale. So where we have to scale? We have to scale with the data, the constantly increase of the business, and we have to scale with the computation because the regulation push us to our limits, and our previous solution cannot handle anymore this amount of computation. We need to be fast as we can. As fast to provide a report, which is the PVs aggregated. We need to be fast on the entire data set and faster on a subset of the data set. Let's say for my portfolio or my book. So a trader has a portfolio and you want to have this report for all these trades. I want to have my report for the desk where there is a couple of traders with their book and so on and so forth. So, and we need to support heterogeneous data set. As I say, the clients have more than one front office system and they want aggregation and a uniform aggregation on all those data sets. And finally, we want to be able to have soft real-time solution. So let's say that I want to have a batch report, but I want to maintain the result on the top of it in a real-time manner. So from that, let's say we will drive our this presentation with 4 main problems. The data, we need to scale with it. The computation, we need to scale with the increasing complexity of the computation. We need to be fast on batch and in real time. And we have to integrate multi-source of data. So in order to scale with the data, as I say, we start to push cache on the top of our database. So what we do is we use Apache Ignite Grid Gain to scale up our data in memory. So for that, you need to know your data because then with this knowledge will come decisions. You can identify some criteria that will help you to put some properties to your data. So the criteria can be the quantity and its growth, the update frequency, and finally, the usage in your business process. So you need to know your data and how you will use it. So let's take 3 examples, the trades. The trades is the pivot of every computation in the pricing model. So you have, and it's a constantly increased data set. So you need to scale out quite easily. So for that, you will use partitioned cache. For the static data, how their name stands for, it's quite stable quantity of data, the amount is quite small, and it's used in every single computation. So you will use replicated cache for the static data. And for the market data, it's a tricky one, because it's used in every computation, the frequency of the updates is crazy sometimes, but the quantity doesn't evolve that much, but the volume is huge. But in fact, when you price a deal, you'd never use the entire data set of the static data. You use a subpart of the market data. So for that, you will use partitioned cache with near cache. And in order to make everything fit into your system and reduce the pressure on the garbage collector, we switch on the off-if mode. So that's it for the data. But what about the computation part? The computation part is more about how we can scale out the computation, how we can maximize the usage of the CPU. So for that, we come up with the following solutions. So first of all, we have a compute grid because our cache is also a compute grid, thanks to Grid Gain for that. Historically, it's even first a compute grid and then it becomes a cache. So in order to scale out your computation, what we did is we used distributed queries, and for that we used compute tasks that we distribute the queries with the compute task, run locally the queries, and then push the documents from the queries into our stream of computation, which we call document flow. We'll talk about it later. So by this way, we collocate computation and data and avoid data transfer between the nodes. So instead of pulling your entire data set into a node and do a compute on it, you broadcast the computation logic on all the nodes, run locally your node, your computation, do your local aggregation, and then do your global aggregation on the request node. This avoid also other data transfer because when you need to compute a price, you need to interact with a lot of data. Not just the deal, but the static data in order to identify which pricer you will use, the market data also, and so on and so forth. And we use streaming. Why? It's because, in fact, with the point-in-time query you can have with Apache Ignite and the continuous query, we can play the both options for batch report and streaming report, real-time report, without having to implement two stacks of technology. So it's more Kappa style of architecture. So how the computation works. We stream everything. And we produce what we call a document flow. This document flow is a composition of processing units, which are our units of reusability and testability. And we compose them through an DASEL, so an embedded DASEL language, domain-specific language. So it produces a DAG. This DAG is a descriptive DAG. We save this DAG into Apache Ignite cache, and all the nodes will be able to instantiate this DAG of computation nodes on each node. And then from there, we can broadcast the query, the task of executing local query, and stream the data through those instantiated document flow. So it achieves the second level of parallelism we can have. The first one is the previous one. We distribute the computation over the node. And the second one is this one, because every processor runs in its own thread. So with the depth of your pipeline, then you achieve more parallelism. But we have a third type of parallelism. Depending on the pricing model or the pricer you have to execute, we can run on GPU. So in this case, the document flow will prepare data, align it in memory, and push it to the GPU. And then we achieve our third level of parallelism through the GPU, and we massively price through the GPU. But it needs to be a special type of asset class. Not all asset classes are compliant with GPU constraints. And after the results come from the GPU or a classical Java pricer, then we push everything into our third technology, which is an in-memory column store. And from that, we are able to do the aggregation, and you see the figures on our UXP interface. So this solves these three levels of parallelism we can achieve through our solutions, and it helps us to scale out the computations. But we need to be fast. And fast means for me not just throughput or low latency in terms of computation, but also avoiding to compute or to see the entire data set when you just need one price or a couple of prices. So for that, we come up with our first classical approach. We say, okay, we are from the RDBMS world, so we know what it means to have a strong data model with normalization and stuff like that. So we decide to implement a pivot model. I come from the Condor world, and since I was in Condor since 2003, I already saw this type of pivot model effort. And it has always failed 7 times when I was in Condor. We tried yet another time, but not just with Condor, with 4 different front office systems, 4 different business analyst culture. And I give you the results, it fails gratefully. Because having those people agree on a business model is quite really difficult. You need a strong governance, and that's really difficult. And also, from a certain point of view, as a consumer, when you see this beautiful pivot model, you don't know what you want, what you would be able to use, because it's too big, too complex, maybe poorly documented, so it's really difficult to identify what you have to use. And as a provider, you may be not able to fulfill the entire pivot model. So where I should put, who will use it for this business use case, and so on and so forth. So you are lost, and it's a bottleneck. And each time you want to add a field, you have to go through a process of governance that is quite difficult to manage. To overcome this issue, we decide to go in some sort of lightweight schema. We decide to identify which are the main information relevant for every single core system, let's say front office system. We have already 4, so if we are able to maintain them for 4, maybe 5, it's okay. So we have what we call the stereotype. Stereotype is a set of sub-stereotype attributes that are commonly accepted by the business analysts. And by this way, it's really a small subset of the information. So all the front office system know where to put the data. What does it mean? There is less documentation to provide just for that. And it offers us a way to, from an homogeneous point of view, access the data with query. And therefore, we use this for indexing also. And by this way, we are able to be faster on small sub-data sets, because we have index on the top of that. So this is how we solve the issue of being fast or faster on sub-data sets than on the entire data set. But what about heterogeneous data source? This is where we have the most complex part. So what we did is, instead of defining a upfront schema, we say, come as you are, like McDonald's, or the sushi principle, the raw is the best. So for that, we have the different front office systems that push data into our cache in the format they think is the best for them. So they have to reorganize a little bit the data because they come from relational database and they need to move to document-oriented architecture, but they keep the maximum information they have because it's 30 years of business engineering and financial engineering. So removing data is dangerous for the future evolution. So we load data as they are. There is a small description of the structure, but every document can have its own data structure. And after that, the system, when the documents, a different type of documents go through the streaming processing framework, the framework will identify the document type, and the processor will say, okay, I want this point of view of the data. I want this field to be able to price an IRS. I don't care about where it does it come from. I don't care if it's a Summit or Sophis or Condor IRS. What I want is those fields, and please provide me. This is where the binder, so it's basically an adapter pattern, will come into the party from the underlying document, extract the requested information, and present it to the processor. By this way, you create a dependency inversion principle solution. You isolate your business from the underlying data structure, and you are able to better test your processor, better test your binders, and isolate the development. So, and finally, as we don't touch too much the original data, we are ready for future developments. It's costly to load those data in memory. So if you have to reload the entire data set each time you want to implement a new business value, then you will lose a lot of time. So this is how we solve our multi-source integration. So for that, I introduced 4 different concepts we have. We have the doc type. So the doc type is a description of the raw document that we load in the system. It's independent from document to document. It's managed by schema. Schema allows us to do backward and forward compatibility. And it will work with the data and the multi-source integration. We have the stereotype. The stereotype is a part of the multi-data source integration because it provides an homogeneous way to query the system, and it also helps into the performance in order to say, okay, give me my report for my trade book or giving my report for my desk. Then we have the document flow, which is our streaming technology that take the documents in their original format, bind them to the requested view from the processor, and doing in parallel. And finally, we have the binders. Binders is the way we transform or we adapt the original documents into our dedicated business view. So, what's next? We didn't end here because Finastra identifies some fact. Today, fintechs want better collaboration, and banks want faster innovation. From there, we come up with the conclusion that collaboration is the new innovation. So, 2 weeks ago, we announced the launch of FusionFabric.code in the Money Market 2020, and we think that this new platform will be for collaboration and innovation. So, how does it work? From one side, you have the creator. So, the banks themselves, the fintech, the university, the independent software vendors that want to innovate. But they want to talk or play with the data that the banks or the financial institute has. And there is a missing point here. So how they can access to those data. Us, as Finastra, we have 9,000 clients from banks, financial institutions, corporates. And we have the products installed in those banks. So what we are doing right now is we are exposing and working on open API on the top of those products and make them available for the creators through FusionFabric.com. So for that, the creator go to what we call Fusion Creator. So Fusion Creator is a low-code application, web application, where with few codes or even no code, you can create simple application on the top of the open API we provide and we connect to the clients, to the banks. Then from there, you create your application and you package it and it will go into Fusion Operate. Fusion Operate will manage, package, deploy your application based on Microsoft Azure platform. And then from there, your application is packaging, ready to be deployed, and you are a candidate for Fusion Store. There you will be able to, the bank will be able to consume your application, you will be able to monetize your application. So this brings three components. So Fusion Creator, where you have a visual low-code development environment with open API consumptions and management. You have a sandbox with a testing tool, all the tool needs by a developer to develop those stuff. Then on the top of, after that, when you have finished your application, then you can package it and Fusion Operate will operate those applications with a powerful dashboard, secure access, and based on Microsoft Azure platform. From there, you will be able to distribute your application, banks will be able to consume your application, you will be able to monetize, and promote your application with a classical way of thing. But what about the impact for what I talked to you just before? My team is working on what we call data lake. Data lake is not, let's say, a classical data lake deployment with Cassandra, Hadoop, and all those stuff. Is how we make available what we load in memory to be consumed on the top of REST API. So for that, we work intensively with Open API initiative, and we provide a set of features that I talked just before. As you can see, we have the document type. So you can list, identify, modify your document type, create new document type. And then you have the documents, the instance of the documents. You can query the documents, you can load the documents, you can push documents that conform to a given document type into the system. You have the schema. As I say before, document types are tightly, have a schema, but they have individual schema. So they want to make evolution, customization on the top of the schema, and this API provides a way to modify your schema in a backward compatible way. Finally, you have also the views and the binder. The views are the business data required by the processor, so the business functions. And here we provide a way to display and define what is the data required by this view or this business process, and this is what you need to provide to the system. You need to adapt from your documents to the processing functions. So for that, we provide the list of the view, the definition of the view, and we allow you to also implement binders on the fly. So as we were thinking that it's for JavaScript developer or web developer, the binders can be described in JavaScript. It's our first implementation. So this is what my team is working on right now, providing all this capability, but on the top of a REST endpoint. And what I see in this is more, how I see it is more like we provide those what we call data lake. We load the data from the core system. We make them available through those REST API, and we provide some really advanced feature as REST endpoint. Let's say the report I was talking about. So, and you will be able to integrate with those data in order to be embedded in those computations. So, lesson learned from the battlefield. So, affinity is a great friend, but it's really dangerous at the same time. You can say, okay, I'm using GPU. GPU is great. It's performed really well on the same type of data. It's IMD solution, so technology. So what about if I put all my IRS on the same node in order to have only IRS to send to my GPU? It sounds like a great idea, but unfortunately, the clients runs not all the asset class. They have maybe loans, or they have maybe IRS, or they have spot deal, or they have different type of asset class, but most of them, they will have something like the 80-20% scenario. 80% of their trades will belong to a single asset class. So at the end of the day, if you do this type of affinity collocation for all your trades of the same asset class, you will end up with all the same threads on the single node. And in fact, only one node will be loaded, and it will fail because it cannot handle the volume. So as affinity need to be used with care. You need to know your model, you need to know how your clients use the data, how the data is used in the computation of your business computations. A better solution could be, for example, the deal and the deal events from the back office, or the exception from the back office. When you have, then if you work mostly from the deal and then you want to iterate over the exception, this is better affinity collocations. So then you have to fight with the garbage you produce. Collocating data and computation is also dangerous. Why? It's because the garbage you produce during the computations will be in the GVM of your data. And that increases the pressure over the garbage collector. And you can end up with a big pause or many pause just because you collocate your computation. In this case, what we did first is we avoid to produce too much garbage in our binders. So for that, we move away from deserializing and serializing the data from the cache. We use binary object from Apache Ignite, which is a zero overhead or zero garbage solution of binary vision of the data. It's like a Bison or Smile or whatever, or flat buffer also. So that's the first option we go through. Then you need to proactively monitor the garbage you produce. And for that, you need an honest profiler. So the best we use for now, and in my opinion it's also the best, we use Java Mission Controller with GFR. So it's the profiler provided by Oracle, And thanks to Oracle, it will become open sources. So it will become part of the OpenJDK effort. And so you will be able to use it in production, because otherwise you have to pay a huge fee. And that's really important. You need to monitor the garbage you produce all over the time. Otherwise, you will end up with huge GC and not will be disconnected just because of the GC. And the third option is you can buy a low-pose GVM, like Azul Zinc GVM. Or you can wait for the ZGC garbage collector for the future version of the GVM, which is low-pose garbage collector, mainly inspired by the Zinc VM. So there is another really important part to keep in mind is the cultural change. What I'm talking about is we developed since 30 years RDBMS-based, relational-based model and database. We open our database to our clients. This is not the best idea we had, but this is the way we work. And so all our developers, and I'm talking about 600 developers, are really thinking in relational way. Moving from relational way to document architecture-based solution, it's really a mind shift. And this is where you need to really teach, educate, evangelize your developers. Otherwise, they will end up with something we saw in our experience. They come up with, they are engineers. So the first thing they will do is I don't want to write code. I will generate code from my RDBMS schema to load my data into my memory. That's because writing code, boring me. I prefer create a generator of code that load data as it is. We say take it raw, but not necessarily as a relational database model. That's really important. You need to really educate your developers. Then they need to think about distributed computing, and that's another story. What I had to work on one integration of the project. What we call the workload is we use Apache Ignite streaming to load the data from the core system to the in-memory compute grid. And some of them were lazy to do upfront the required transformation. And so they use one stage we have in our system to recompute or remodify the data post workload. And when I saw the code, it was really something like iterative and goes by the wrong direction from the data. Just by reworking the way the system behaves in distributed grid, we gain something like 1 or 2 orders of magnitude of performance just for this step. I was against this step, but just in order to make it work, you need to really think about distribution and the way you compute against the distributed system. So, and then there is a really important thing also when you work in distribution is how you understand where the time is spent. That's nothing. Apache Ignite doesn't come with any feature for that. Where all my functions behave on these nodes, where is my time spent in my document flow? Which processor is the slowest? Do I have to increase the number of threads in order to? Those questions are quite difficult to solve if you are totally blind. And for that, what we are using is we integrate with open tracing. Open tracing is an open solution that comes from, I think it's Dapper, yeah, something like that, from a Google paper. Zipkin was the first open source version of this open source Google paper, and then there was joint effort for implementing open tracing. It's like Open API initiative. It's the same idea behind the hood. And with open tracing, you are able to see a distributed graph of the execution of your document flow, of your distributed computing. And by this, you are able to identify where you lose time, which server is the slowest. Is there some lag in the network? So it's really, really important in order to identify and identify where is your issue. If you have a lot of money and you are ready to be really locked with a vendor, you can use App Dynamics. It's a great tool. We are using it in production, but it's way too expensive to use it in development. So we have something like, we adapt open tracing to App Dynamics in order to be able to leverage on App Dynamics, because App Dynamics is really an advanced tool for that. So that's it. So just to conclude, I want to show you the video of the launch of Fusion Fabric Cloud, and then we can